Dear friends, I myself, Dr. Bharat Parab, discussing the topic direct and inverse proportions. Introduction of proportion. The word proportion itself means a ratio. To understand this, consider these examples. First one, if cost of 1 kg of sugar is rupees 30, then cost of 2 kgs has to be rupees 60. Very simple. 1 kg is 30, then 2 kg will be 60. Second one, if one container can hold 1 liter of water, then 10 such containers would hold 10 liters of water. This is also another simple example. Third one, listen this very carefully. If a car travels with a speed of 10 kilometers per hour, then it will take 2 hours to cover a distance of 20 kilometers. 10 in first hour, 10 kilometers in second hour. But if car increases the speed to 20 kilometers per hour, then it will take 1 hour for the same distance. Okay, just go through it. We will discuss something on this after this. And fourth one, rupees 1000 are to be distributed amongst 10 students. Then each will get rupees 100. Very simple. But if this is constant, that these rupees are to be distributed amongst 20 students, then each would get rupees 50. What have you observed in this? This, just see, when in first and second, the weight increases, price also increases. Or here, if the container increase from 1 to 10, then capacity also increase from 1 to 10. But here, the speed is doubled, time is halved or half, takes half term. That means this is this increases, this decreases. Similarly here, when 10 students, 100 rupees, but when students are increased to 20 students, then the amount decreases to 50. So this is going decreases when this increases. This is what is given in this comment. So in example 1 and 2, we observe that as one quantity increases, other also increases. This also increases. This increases, this also increases. But in example 3 and 4, as one quantity increases, this decreases. This increases, speed increases, time decreases. So one quantity increases, the other decreases. Okay. So this is a very simple funda. So in example 1 and 2 is a direct proportion and 3 and 4 is inverse proportion. We will see this in details in further part. Now study in details direct proportions. We will take the same example of sugar. Let us take example number 1. Read it. If cost of 1 kg of sugar is rupees 30, then cost of 2 kgs has to be 60. Okay. So we will only consider on this example. We have to convert this statement into a mathematical language. Okay. And how to convert that? See here. if weight, that is this kg, is denoted by x, so for weight we consider x, and cost, rupees, this is denoted by a y, then we see that as x increases, y also increases, y also increases. Okay, so we write it as x, the symbol, and y, and it's read as x varies as y. So this symbol means varies as. Okay, so whenever you come across such equation, read it as x varies as y, and we have to introduce equal to sign, and it is introduced like this. We take x is equal to some constant k into y, where k is a constant, or if we cross multiply here, x upon y is constant. Okay, so looking at this is equation for direct proportions. Okay, so therefore if x takes different values as 1, 2, 3, then y will also take corresponding values as 30, 60, 90, etc. Okay, so we have developed a table here where x and y varies according to this statement. If it is 1, it's 30, if it is 2, 60, then 3, it will be 90, 4, it will be 120, and 5 will be 150. Okay, as x upon y is equal to k, we see that we will continue the same thing on the next slide. So we are continuing with the same example. So I have copied the table here to understand it. 1 kg, 2 kg, 3 kg, and the corresponding values of y, denoted as first value as x1 y1, x2 y2, x3 y3, like that. As you know, x upon y is equal to k is some constant. We will see the first value x1 upon y1 is 1 upon 30 is k. Second value 2 upon 60 is equal to 1 upon 30 again, it's k. Now here 3 upon 90 is equal to 1 upon 30 is equal to k, and will all x5 upon 5, we get this. So we see that x1 upon y1 is equal to k, x2 upon y2 is equal to k, x3 upon y3 is equal to k, like that. All x5 upon y5 is also equal to k. So if we take only this, x1 upon y1 is equal to k and x2 upon y2 is equal to k, that means x1 upon y1 is equal to x2 upon y2. Okay, so ultimately we arrived at this equation. Now we are rearranging and bringing this x1 on one side, this will go down by cross multiplication. So x1 upon x2 is equal to y1 upon y2 is a final expression. So direct proportion means the variables follow the pattern as one increases, other also increases. Okay, and this is the mathematical form of this, at x1 upon x2 is 1 upon 2 is equal to 30 upon 60 is also 1 upon 2. So do remember this for solving problems, and we are tackling some problems now, some problems on this way. Okay, exercise 1, read it. A mixture of paint is prepared by mixing 1 part of a red pigment with 8 parts of base. Okay, generally a paint is never applied directly, it has to be mixed with a base. Here the proportion given is 1 part of red pigment with 8 parts of base, 8 parts. In the following table, find parts of the base that needed to be added. Now this is given that if we take one part is a red pigment, one part base is added 1, then we have to calculate for 4, 7, 12, 20 parts of red pigment. This we have to calculate. Now answer, we have to convert this problem into a mathematical expression like this. Let the parts of red pigment be denoted as x and that of base be y. Then we have to prepare this table in answer sheet and denote this as first value as x1 y1, second will be x2 y2, third will be x3 y3 for us to solve this problem. Okay, so red pigment x and y. So if you write this, then no confusion should take place. Okay, now x varies as y or x equal to ky, where k is a constant or x upon y is equal to k. We are taking advantage of this or the formula which has been derived, x1 upon x2 is equal to y1 upon y2. This is the final formula we have seen. X1 we have, x2 we have, y1 we have. So out of 4, 3 quantities we have, y2 we have to calculate. This is written after calculation. So don't consider this in the beginning. Okay. So substitute now x1, x2 is equal to 8 upon y2 which we have to calculate. 1 upon 4 equal to 8 upon y2. Now cross multiply. This will go there, this will go there. So y2 equal to 8 into 4 is 32. This is 32. Written after that. Now x1 upon x3 equal to y1 upon y3. See, this is corresponding. Okay. So similarly here, substitute 1 upon 7 x3 I am talking about equal to 8 upon y3 which you have to calculate, cross multiply. So y3 is 7 into 8 is 56. Okay. Similarly, x1 upon x4, this is here, 12 into 8 is 96, and for 20 it is 160. Go through it, learn it, and have some exercise and think over it. Okay. So this is a example of a direct proportion, and part of this problem is tackled in the next slide, which is very interesting. Okay, so we will see that. Read this example 2. Part of this is same as the previous example. There is a little extended part in this, but we have to read it. A mixture of paint is prepared by mixing 1 part of red pigment with 8 parts of base. We have done this. Find the parts of the base needed to be. This was the previous example. Red pigment and base 1, 8, 4, anything, something like that. Okay. Now, what is the extended part is in this problem is 1 part of red pigment. We have drawn this table here. Okay, 1 part of red pigment. Here it was 8 parts. Now he has given us 75 ml of base, that is y1 here. So 1 part requires 75 ml. Then how much red pigment x2 should we mix with 1800 ml? See here of this. How many parts? Okay. The one he has asked part only. Okay. So answer, let us put it in a proper way. Part of a red pigment is 1, part of base is 75 ml. Then x2 is unknown to be found out. and y2 is 1800. Now this is a formula, x1 upon x2 equal to y1 upon y2. For this, don't make any mistake in writing this. Now x2 we have to calculate, so 1 upon x2 equal to 75 upon 1800, and if you cross multiply this will go there, so it will be x2 equal to 1800 upon 75 is 24. So x2 is 24 parts of a red pigment should be mixed with 1800 ml of the base. Okay, we have calculated parts. Now I have given you some exercise. Can you calculate this in ml? As we are dealing with ml for the base, then why not calculate ml for the red pigment? Okay, give me in comment section. If you cannot do it, no problem. Thinking is very important. You may get answer, you may not get answer. I will help you in getting answer. But if you think that might help you in the some future problems, or your thinking might help you in somewhere in maths. Okay, so move ahead. For example, read it very carefully. Such type of problems are really very interesting, but you need to read these very carefully and write the quantities in a right place. Okay, go through it. A photograph of bacteria enlarged 50,000 times attains a length of 5 centimeters. This has some bacteria has some length and is enlarged 50,000 times, and after enlarging it attains 5 centimeter on the microscope scale. Okay, as shown in diagram. This is the bacteria. What is the actual length of the bacteria? Actual length is something different. After magnifying it for 50,000 times, it requires a count of 5 centimeters. Okay, got it? We are supposed to calculate the actual length of the bacteria. If photograph is enlarged 20,000 times only, then what will be the length of the enlarged part, or what will be its enlarged length? Okay, you may so happen that we don't have a powerful microscope, then instead of 50,000 we can only enlarge to 20,000, and the enlarged length will also be less. Okay, so answer. So we will prepare this table like this, so that a right value can be written in the right box. Actual length of the bacteria is given x1, x2, x3 like that, and enlarged by or enlarged to. Now here, when this was enlarged to 50,000, we were getting 5 centimeter. So x1 is 1, y1 is 50,000. This is enlarged length 5. What is the actual? Okay. So we know that x is directly proportional to y, or x equal to ky. This you know by this time. X1 upon y1 equal to x2 upon y2, and rearranging this final we get x1 upon x2 equal to y1 upon y2. So we continue these calculations on the next slide. Okay, continuing with the problem from last slide, I have copied the table here. Just see here, actual length of the bacteria and enlarged by or enlarged to. So here x1 is 1, then y1 is 50,000. This is centimeter, is written here. So when this 50,000, this y2 is 5, and we have to calculate x2. Okay, we have a formula x1 upon x2 equal to y1 upon y2. Well, then substitute x1 is 1, x2 we have to calculate, y1 is 50,000 and y2 is 5. So cross multiply, x2 goes up, 5 goes up, 50,000 comes down. So it is here. X2 equal to 5 upon 50,000 is 1 upon 10000, that is 0.0001 centimeter, and this was in centimeter. That is equal to 10 raised to minus 4 centimeters. The actual size is 10 raised to minus 4 centimeters. Now after doing this, we will tackle the next part of this exercise. See here, the actual length of bacteria is this. Enlarged part we have to calculate. If this is enlarged only 20,000 times. Okay. So here we know actual size and enlarged for 20,000. Think over it. You yourself think over it. You will get it. X3 upon X2 equal to Y3 upon Y2. So X3 we have, X2 we have, Y3 we have, Y2 we have to calculate. Cross multiply. This will multiply with this. Y2 goes there. Y2 equal to 20,000 into 0.0001, that comes out to be 2 centimeters. Okay, so enlarged 2 centimeters, that's why return after calculation 2 centimeters. Okay, so think over it and try to solve some problems of this type yourself, and thinking will definitely help you. Okay, exercise 4, read it very carefully. In a model of a ship, a mast is 9 centimeter high, while the mast of the actual ship is 12-meter high. If the length of the ship is 28 meters, how long is the model ship? Now, generally, when big ship is manufactured, generally a small model of the same dimension, having same dimensions, is prepared and given to the customer, and a length and breadth and everything are is same, the dimensions are same, they are in proportion. So this is a problem of that type. So this is the model. We go for the answer. So try to prepare such a rough sketch. Okay, this is a model of a ship. This is a length of the ship, model ship, and this is actual ship. Just consider this is actual ship, and the mast is 9 centimeter high. This is the mast of the model, 9 centimeter, and this is of the actual ship, which is 12 meters. That's why this is centimeter and meters. Okay. Now what he says, if the length of the ship is 28 meters, this will be also in that same proportion. Then what is the length of this, or how long is the model ship? That is, he has asked the length. So we'll prepare this mathematical expression by using these denominations. X1 for mast in model, and x2 x1 x for model. So mast x1 and a length x2. Similarly here, mast y1 and length y2. Now prepare this table. Model of a ship 9 centimeters and length which we have to find out. An actual ship for 9 it is actually 12. Then for actual 28, how much this is? This is, I have written this after calculation. Originally it was only this much. Okay. So it's a direct proportion example. As a mast and the ship size both increases simultaneously. Hence x varies as y. So we use that the famous formula x1 upon x2 equal to y1 upon y2 and substitute all the values. X1 is 9, x2 we have to determine, and 12 upon 28. Therefore, if you cross multiply here, you get this will come here, 12 will go down, and this will go there. Like 9 into 28 upon 12, and you get answer 21. That is the model ship is 21 centimeters. Don't forget to write these units. So I have written it here. Okay. So we solve as many problems as you can, and it will be very simple subject for you. Okay. So we move ahead with this exercise 5, fifth one. This is actually, these are two problems combined. So we will tackle one by one. Read it very carefully. In fact, all the mathematical problems you should read very carefully so that you understand the data very clearly. Okay. Read it. A 5-meter 60-centimeter high vertical pole is a vertical pole cast shadow of 3-meter 20 centimeter long. Okay. Find at the same time, remember, first one, the length of the shadow cast by another pole 10 meters 50 centimeters high, and second one, height of a pole which casts a shadow of 5 meter long. First we'll see the first one and try to solve this. So answer, let us draw a rough sketch of the data given in the problem. We read it again. A 5-meter 60-centimeter high vertical pole. So we have drawn a pole here and named it 5-meter 60 centimeter. We have given the dimensions and we have considered for pole x1. Okay, for pole and this pole x2. The height is considered by x and length of the shadow by y. You can consider anyhow you like, but if height is x, then this also should be in x. If this is y, this also should be in y. Okay. So 5-meter 60-meter high, this is given, high pole, high vertical pole with a shadow of 3-meter 20 centimeters, y1. Got it? Then at the same time, length of the shadow cast by, he has asked the length of the shadow, so this is asked. Okay, that is why a rough sketch is very important. Okay, this gives you clear idea of what we have to solve and what is given data. Okay, length of the shadow cast by another pole is another pole 10 meters 50 centimeters high. So always, whenever possible, draw rough sketch. If such type of problem is given, we have drawn this in the previous problem also. This makes your problem very easy. Okay, now prepare this table. Pole height, that is x1 x2. Okay, 5 meters 60 centimeters, 10 meters 50 centimeters, this, okay, and length of the shadow 3 meters 20 centimeters, and this we have to find out. Now, very interesting, see, I have given a comment here, convert meters and centimeters to centimeters. So never keep it like this, meters and centimeters like this. Convert it in a suitable unit. 5 meters and 60 centimeters is 560 centimeters. Convert is only one unit. You can do other way around also, but that may be little difficult. So do it like this. 5 meters 60 centimeters is 560 centimeters. This will be 320 centimeters, and this will be 1050 centimeters. Okay, remember this 10 meters, not 1 meter. Okay, so 10 will be there, and this 50 will be there, so many centimeters. Now this is very simple problem. Okay, so we know that x is directly proportional to y, x varies as y. So we use the famous formula x1 upon x2 equal to y1 upon y2, and substitute, we have x, we have y, all the values. So while selecting this or writing this, don't make mistake. Okay, then problem is very simple. So this is 560, x2 is 1050 equal to 320, and y2 which we have to find out. Okay, cross multiply, but it should go there, 320 should be multiplied with 1050, and 560 should come down. After solving this, get 600 centimeters, that is 6 meters, the length of the shadow. Okay, so we have converted these centimeters into meters again. If you don't convert it, no problem, but you have to always denote this unit. If you are writing 6, it should be meters. If you are writing 600, it should be centimeters. So this is the first part of this. We will try to solve this, the second part, in the next slide. It should be very simple for you if you understand this. Okay, so we move ahead for this. Okay, so this is example 5, second part. So we read the data which we need here. A 5 meter 60 centimeter high vertical pole casts a shadow of 3 meters 20 centimeters long. That is what is seen in the last problem also. Find at the same time the height of a pole. This time he has asked height which casts a shadow of 5 meters. Very simple now. We have prepared this rough sketch in the previous one. This sketch will be same as the previous one. This will change. We have taken x3 for this, and this is the pole. We have to find out x3, height of the pole. Y3 is given as 5 meters. Okay. Now again the table. This is same as in the previous one. Pole height will be 5 meters 60 centimeters is 560 centimeters. Length of the shadow will be 320 centimeters. This we have to find out, and this is 5 meters. As in the previous case, we have converted all this into one unit, as is centimeters. 560 upon 560 and 320 and 500 centimeters. We know this is a directly proportional problem, that x varies as y, and we are using this formula again, x1 upon x3. Remember, this is x3. Okay, equal to y1 upon y3. We have to write like this. For in the same problem, don't make jumbling, as we have used x2 and y2 for some other pole, then for different pole or different problem in the same problem but different part, use like this. Okay, so that you will not get confused, examiner will not get confused. Okay, so x1 upon x3 equal to y1 upon y3. Substitute. Now it is very easy. You know x1, you know x3. You have to find out x3. You know y1 and you know y3. Okay, so this is kept as it is. Now after cross multiplication, this will go up. 560 into 500 will be there, and this will come down. So we have done it here. And after solving this, you get 875 centimeters. That is 8 meters and 75 centimeters pole height. Okay, this is very simple one. So we write it. It is written after these calculations. Okay, so this is your answer. Okay, to try to solve some more problems and try to solve it yourself, then only you will get some practice and you can understand it in better manner. Okay, so we move ahead. This is Dr. Bharat Parab helping you in your studies. If you have any difficulty in this topic of direct proportion, let me know through comment section and I shall solve it. Thank you. If you have any difficulty, do come. Okay. Good luck.